All right, this is our lesson on 4.5, solving quadratic equations by finding square roots. As a matter of fact, a lot of this lesson is just about square roots. Look at objective 1 right there, to use properties to simplify square roots. I don't mean just putting something into the calculator and finding a square root. I mean, if I have the square root of, say, 44, can I put that into simpler form? Okay. Rationalize a denominator by multiplying by a conjugate. We can't have square roots on the bottom, and that's what this is about, is taking care of that. And then finally, putting those things together so that we can solve quadratic equations by taking a square root. So if you will recall, when we first learned to solve these quadratic equations, we've only done it by factoring. So that's what we're going to do here. And the rationale is this. It's called the zero product property. Remember that if I have two things, multiply them together to get 0, this means maybe A equals 0 or B equals 0, or maybe both of them. Okay, so we have to factor this side of the equation. And that looks to me like it's the difference of two squares. And that factors as x plus 2 times x minus 2. Okay, and then in turn we set each of these things equal to 0. X plus 2 equals 0, so x equals negative 2 when you subtract it over. Or x minus 2 equals 0, so maybe x is just equal to 2. Usually we write this as x is equal to plus or minus 2. Okay. If you remember when we first talked about quadratics, the shape of this thing would be a parabola, and this positive and negative 2 is where it would touch the x-axis like so, the zeros, right? Oh man, what a fantastic looking parabola that is. Okay, so question is, could we solve this differently? And the answer is yes, we can solve it by taking a square root. And so what we do is take that equation, and instead of factoring the left side, just add the 4 over to the right hand side of the equation. And then what's the inverse of squaring? Because we have to undo that x squared. It's to take the square root. So you take the square root of both sides. And over here on the left side, these two are going to cancel out because a square and a square root are inverses. So we're just going to be left with x is equal to the square root of 4, which is 2. But didn't we just say that it's supposed to be negative 2? What's up with that? Where's that other solution, negative 2? So that's part of what we're talking about in this lesson. So here are vocabulary, square root. We just saw a couple of these. Well, we just saw one of them anyway. How about, say, something like square root of 2? That's most people's favorite square root. I tend to agree. A radical, square root, radical, used interchangeably. Radical sign is the thing that looks like a little check mark or division symbol. Radicand is the number that's inside of this. We'll talk about these words a little bit more in just a second. Principal square root is the positive one, so that's the one the calculator is going to give us. And perfect square, we know these numbers like 1, 4, 9, 16, and so on. Conjugate. Conjugate as a word means they're the same or similar, but they're also opposite in some way. Is that confusing? All right, fair enough. And finally, rationalizing the denominator. If I have a square root on the bottom, like 5 over the square root of 3, you can't have that square root of 3 on the bottom, so you have to get rid of it. Okay, so our first objective is just simply using properties to simplify square roots. What you see growing here is a square root spiral. It's going to stop at square root of 15, but this thing should keep going on and on and on. And it's a nice way to visualize all of the, like geometrically, to visualize irrational numbers. So it starts with this isosceles right triangle right here. Legs are 1 each, and if you use the Pythagorean theorem, then you get square root of 2 as the hypotenuse. And then you add another 1 for a leg, use the Pythagorean theorem, you get square root of 3 for the hypotenuse, and you just keep going on and on and on. And it's super cool. Okay, so here's the definition of a square root. Square root, Rowan, remember be quiet, okay? a number r is the square root of x if you have to square that number to get x back. So here's just an example right here. For example, 5 is a square root of 25 because 5 squared is equal to 25. Okay? All right, well, isn't there another one? Can't I say that negative 5 is a square root of 25? Because I think negative 5 squared is also 25. And the answer is yes. So we usually write the square root in one of these little radical symbols. The number on the inside is called the radical, or radicand, I'm sorry, and the whole entire thing is a radical. Okay, so anytime I take the square root of a positive number, there should be two answers, a positive one and a negative one. If I scroll back to this, that's why I said that 5 is the square root of 25, and so is negative 5. So I should always have two answers. So there's another example there. The square root of 4 is both positive 2 and negative 2, since if I square either one of those, I get 4 back. The positive one is what's called the principal square root. It's the one that this square root symbol usually refers to. It's also the only one that the calculator is going to give to you. So speaking of calculators, let's do a little calculator investigation to see if there are some properties to help us simplify some square roots. So let me call up this calculator here. Here we go. Turn this sucker on. Ah, look, I've already done it. Here, let me clear that out. Okay, so I'm going to type this in like I see it. Square root of 3 times the square root of 2. And I don't have to do the little parentheses like that are typed on this slide because this has the newer operating system and it's unnecessary. I just have to press the arrow to get out of it. Okay, so I hit enter. I have this nice little irrational number. Now let's see if I could just multiply the square root of 3 and 2 together to get square root of 6. Let's see if that's the same thing. So square root of 6, enter, and oh, look at that. It is the same thing. Excellent. Okay, so I'm going to make note of that. So these two are the same. And what that means is whenever we go to simplify square roots, one thing that I can do is multiply the radicands together. Let's try it with division here. Pull the calculator back up. So rather than me typing that in again, I can just go back and get it. Turn this times into division. There we go. And now let's do the square root of 3 divided by 2. I can type that in or just be lazy and put 1.5. Okay. Oh, it's also the same thing. What do you know about that? So I can also divide two square roots, divide the radicands, and get the same answer. Okay, let's try it with adding and subtracting. It works with multiplying and dividing. Why can't it work with adding and subtracting? Let's try it. So let me go back up here, scroll up, get this one back and turn that into a plus. There we go. Wow, that's almost pi, but not quite. How about the square root of 5? And they're totally not the same. Definitely make note of that. Not the same. So whenever you're going to simplify square roots, you can't just add the radicands together. That doesn't work like multiplying does. Let's try the subtraction, right? Addition didn't work, maybe subtraction does. Go back up here, pull that back in, turn this into subtraction. Just a minute, babe. And then, or if I just subtract them, square root of 1. Do I need to put that in? Square root of 1 is 1, right? Well, for all you non-believers out there, there you go. I can see that's not the same. So to summarize this, I can't add or subtract radicands to simplify square roots, but I can multiply and divide. Alright, see you in the next video.